A very good morning to all the students for the today's session. So today we will be discussing about the very important aspect, so as far as the lathe machine operations is concerned. So before we proceed with the today's session, just I wanted to revise what we have discussed in the previous session. So in the previous session we have discussed about taper turning, okay, and in that what are the different methods of taper turning, and these two important operations are very important, that is taper turning and the thread cutting, because today we are going to discuss in detail about thread cutting. Though we have discussed as one of the operations which can be carried out on a lathe machine, it is necessary that we require to adopt certain methodology. Means whenever we are going to carry out the taper turning operation, we are going to adopt various methods depending upon the diameter of the workpiece, depending upon the length of the workpiece, and depending upon the availability, like whether we are going for a compound rest swiveling method or whether we are going for a tailstock set over method, like that, which we have already discussed in the previous session. So today it is very important to understand how the production of the thread cutting is actually carried out on a lathe machine. So that is what we are going to discuss in the three important concepts today. That is, the first one is what is the meaning of a thread cutting. So all of you know very well that if at all we want to join any two metals, any sheet metals, whatever is there, whenever there is a requirement of joining the materials, then always we go for various methods like using the bolts, using the screws, using the what we can say riveting. But here we are even welding also, but here we are going to understand how this, whatever, suppose if you are going to take a simple hexagonal headed bolt or a square headed bolt, it is, or a stud, it is having what, the threads being generated on its surface. So how it is actually generated, how it is being produced, so that all concept we are going to discuss in detail in connection with the today's session. So let me start with the meaning of first thread cutting. So there are a large number of thread forms that can be machined in lathe. So depending upon the profile, here depending upon the thread forms means what, the formation of the threads means the angle of threads whatever is there, so that has been defined by various at the international and national levels, about like Whitworth type of thread we want to cut, or Acme threads, or ISO metric, etc. So that we are not going to discuss in detail, because these concepts you have already studied in your engineering graphics to some extent, and also in the machine drawing subject. So we want to understand how the thread cutting operation is being carried out. Okay, thread cutting can be considered as a turning only. This is very important. So thread cutting, actually it is as good as a turning operation, because in purely turning operation our aim is to only remove the excess material, means reducing from larger diameter to smaller diameter of a given cylindrical workpiece. So that is called as a turning. The methodology is same, but only thing is we require to control the feed rate here in an automatic fashion. So that is what we are going to discuss in detail in the subsequent presentations. Since the path of the tool to be traveled by the cutting tool is helical, because here it is very important that the tool has to cut the helical grooves. That is called, whatever the formation of the teeth is nothing but a formation of a helical grooves. So how this is being produced, that all we are going to discuss now. So before we proceed with the production of the thread cutting operations, we need to understand some of the concepts here just as a basic information. So when already you are going to see on the screen, the left portion is provided with what, the type of a thread. So generally whatever the type of thread is there, it is definitely a V thread only. So in that you are going to see various nomenclature, means naming of various components of a thread. So in that you know about first nominal diameter. So nominal diameter, which you are going to see to the right side here, nominal diameter is considered to be the larger diameter. Okay, means, or also we can call it as a major diameter. First, because at the beginning the workpiece surface will be like this, we don't have any threads, so that is why it is called as a major diameter. So the next concept coming is what? That is also called as an outside diameter, which you are going to see this side. This is called as an outside diameter, and nominal diameter have got same meaning, there is no difference. So inside you are going to see the root or core diameter. So this root or core diameter is very important, because basically the depth of the thread decides that. The depth of the thread, so whatever the depth you are going to see, how much depth we have to give, so that decides. Okay, taking into that consideration, it is possible to what we can say, taking into consideration the depth of the thread to be cut, we can calculate the root or core diameter. So as per the sketch, you can understand that if at all I want to calculate the root or core diameter of the thread, it is outside diameter minus 2 times depth, because depth is considered on either side of the threaded portion. And also the most important part which you are going to see on the screen here is pitch. This is a very, very important definition as far as the thread terminology is concerned, because we are interested, our main focus is to see that the feed rate, whatever we are going to give, whenever we want to produce the threads, we have to maintain the feed rate equal to the pitch of the thread to be cut. That is very, very important, because that is the main concept here on which the thread cutting operation is being carried out on a lathe machine. So also you are going to see here clearly the root. These are the different parts, root, and this is called as a crest. There are two important terminologies, that is the topmost portion is called as the crest, and the down portion of the thread we call it as a root. So if at all I want to define the pitch, it is the distance between the two successive crests, CRESTS, as you are going to see clearly on the screen. Okay, so now we are going to start with the main concept, that is depending upon. So now we have discussed about the terminology in connection with the screw threads. So now we need to understand, because it the major role played whenever we want to go for the production of the threads, it is the pitch that decides. Okay, so in that also we need to understand there are two terms coming. One is called as a pitch, another one is called as a lead, LEAD. So lead is generally considered as a two start. It is also called as a two start. Okay, so why it is called as a two start? Because so in the left portion you are going to see one start or single start. So whenever single start means what? If at all you are going to see the circumference of this, so that means this is your circular top view, rough top view of the single and multi-start thread which I have drawn there. See, one cutting can start from here and another helical groove or cutting of the thread can start here. Suppose if it is starting from here only one portion, then it is called as a one start. Suppose one more thread is going to be cut on a surface of a workpiece from this end, then it is called as a multi-start, or also called as a two starts. So this is just a basic concept for understanding. So we need to know that what is the difference between single start and multi-start thread, and along with that the most important concept here to be understood is called as a pitch, which is considered as the distance between the two crests, which I have already discussed. So the next one coming up is right hand thread and left hand thread. This is also an important concept here, because we need to understand one important thing here is whenever we are going to cut the threads on any type of workpiece or any material surface, cylindrical surface especially, in that we need to understand what is the meaning of a right hand thread and what is the meaning of a left hand thread. Okay. Whenever you need to understand here, right hand thread is the most commonly used type which you are going to do in your machine shop. On a lathe machine, generally you are going to cut the right hand thread. Okay, depending upon the specific applications, okay, left hand thread can also be produced. So let us have an understanding about what is the meaning of a right hand thread. Helical ridge of uniform cross section onto which nut is threaded in a clockwise direction. So that means whenever I am going to start putting the nut on the given threaded part, if at all the nut is made to rotate in a clockwise direction, then it is called as a right hand thread. That is the only thing. When cut on lathe, the tool advances from right to left. That means whenever I want to cut the right hand thread, I have to see that my cutting tool is made to move from right to left. That is from the tail stalk towards the headstock. The cutting of the thread has to be done from the tail stalk end to the headstock end. Then we are going to produce the right hand thread. So exactly reverse is the case when we want to go for the left hand thread. We have to start cutting from the headstock to the tailstock side. Then we are going to form the left hand thread. Helical ridge of uniform cross section onto which the nut is threaded in counterclockwise direction. So a very simple understanding is whenever I am going to rotate, first I am going to hold the screw or the threaded bolt, and when if at all I am going to make the rotation of the nut clockwise, then it is a right hand thread. If at all I am going to make, and it has to advance towards the head of the bolt, that is very, very important. Suppose if the nut is made to advance inside by rotating in a anti-clockwise or counter-clockwise direction, then it is called as a left hand thread. So we are not interested, only to understand purpose we are discussing about these concepts. So the next concept coming is about thread cutting operation. Now this is a very, very important point to be noted here. Just we have shown in the figure, workpiece is made to rotate as usual in a headstock chuck, and the original diameter D, which I have told, that diameter is also called as the major diameter or the nominal diameter of the workpiece, on which we want to cut the thread of a particular pitch value. Even we have to decide the length of the thread also. We have to decide what should be the length of the thread on a given workpiece. And our intention here is to control the feed rate of the cutting tool. The most important concept in a thread cutting is to control the feed rate in a precise way, in a correct way. Let us define it. A thread is a helical shaped groove. Just we have discussed. Again, we are just repeating it. So we know what is the meaning of a thread. So a thread is a helical shaped. If you are going to see, to give a simple example, if you take a ball pen spring, inside there is a spring. That spring is in the form of a helical type. That formation is called as a helical shape. The same one is also produced on metals here. That is what we are discussing, formed on cylindrical surface of the workpiece. Thread cutting is an operation performed on a lathe to produce threads by using tool whose shape will be same as that of the thread. This is very, very important concept. So now generally we consider we are having three important types of applications or forms of threads. So one is called as a V thread, and another one is called as a square thread, and the third one is called as a Acme threads. So what is the meaning of this? Let us have a brief discussion. So V threads means the angle of it is a V shape. So this is the most commonly used type where it is provided on your regular screws and your bolts. Okay, so bolts are provided with the V types of threads. And if at all you want to go for a design of a screw jack, there you are going to have either square threads or you are going to have a Acme threads. So in a square thread, if you are going to observe, the threads are if you take the cross section of the thread, you are going to see it is a square portion. So in ECME threads, it is a trapezium type shape is there. So that is why we need to understand there are three types of threads which can be cut on a lathe machine also. So in that, our intention main is to focus on the V thread formation. So V threads means what? Whenever I want to cut the V types of threads, then I have to select a V shaped cutting tool. So this is an important point to be noticed here. Okay, so now we are going to discuss in detail again about how the thread cutting operation is being done. Workpiece is revolving between the centers or by a chuck. So this is very, very important. So either the workpiece is held either in a chuck or between the centers. If your length of the workpiece is very long, then definitely we go for the supporting of the workpiece, or it is made to revolve between the live center and the dead center, along with your some rests, RESTs, which we have discussed in the previous sessions. As shown in the figure, the longitudinal feed should be equal to the pitch of the thread to be cut per revolution of the workpiece. This is very, very important. So now we require to control the feed rate, which should be equal to, as I have indicated there, which should be equal to the pitch of the thread to be cut on the workpiece. It is necessary to calculate the speed ratio, which we are discussing now. See here, again I am going in detail about that. Just I am reading, try to just understand now. Again we are going in detail about these concepts, because this is a very important aspect as far as the practical application is concerned. Whenever you want to carry out the thread cutting operation on a lathe machine in machine shop, you need to understand all these concepts clearly. In this operation, helical grooves are produced over the cylindrical surface of the workpiece, which I have already informed. For thread cutting operation, a definite relationship between the rotation of the workpiece in the spindle and the longitudinal travel of the carriage is required. So that means, as we are controlling the feed rate, this feed rate value of the workpiece should be always equal to the pitch of the thread. Suppose if the pitch of the thread is 2 millimeters, then for one revolution of the workpiece, the cutting tool has to move equal to 2 millimeters. Suppose if 1 millimeter pitch is there, I want to cut on a workpiece of 1 millimeter, then I have to see that our cutting tool is made to move through a distance of 1 millimeter for each revolution of the workpiece. So this cannot be done manually. For that purpose, we are going to take the help of a carriage. Okay, this is done with the help of engagement of the lead screw. That is what he is telling here. We require to engage the carriage to the lead screw here. That is very, very important. After engagement of the lead screw, the whole carriage unit moves forwards from tailstock towards the headstock, and backwards, that is from headstock towards the tailstock, by controlling the levers that are provided on the apron unit. That apron unit, the whole unit, whatever you are going to see, that is called as an apron unit. The tool moves specific lengthwise, which is parallel to the center line of the lathe machine. Okay, the feed rate is provided with the help of a cross slide. During this operation, the workpiece is rotated at a very lower speed. So generally what we are going to do here is, the speed of the workpiece controlling is very, very important, because we cannot rotate the workpiece very fast, as which it can be done in a regular operation like turning. So here we require to control the speed of the workpiece nearly to 50% of the turning operation. So again we are discussing in detail, try to understand, because whatever the sketch which you are going to see, that is called as a top view of the lathe machine. So where we have shown here few important elements. So now you are going to see very clearly, this is nothing but your workpiece which is being held between the two centers, that is headstock center and the tailstock center. And the next one which you are going to see, this is the whole portion, this is called as the carriage unit, which is made to move either towards the headstock center or towards the tailstock center depending upon its engagement to the lead screw. So you are going to see on the screen clearly there the carriage, okay, which is engaged with the lead screw, means which is connected with the lead screw, okay. There is a screw and nut mechanism is there, split nut is there inside, which we are not shown there, which can be engaged or disengaged. That means the carriage can get the engagement or disengagement with the screw and nut mechanism. So now as you are going to see clearly here, you are also going to have a tool post. So which you are going to see here, this portion is called as a tool post also. So now here you can see that the lead screw is going to act like a regular screw and your carriage is going to act like a nut. Suppose if at all I rotate the lead screw, what happens? The carriage will start moving in either directions. So that depends. So when I am going to rotate this lead screw, simple understanding, because this lead screw is in connection with the carriage will start moving either to the right side or to the left side due to rotation of the lead screw. So in other words, we can say the carriage is going to act like a nut and the lead screw is going to act like a regular screw. That is the main concept here. And one more very very important thing which you are going to see here is spindle gear, lead screw gear, they are and intermediate gears, or they are also called as the idler gears, which are provided between the spindle gear and the lead screw gear. These are used for the transmission of the power, because we require to transmit the motion or the power from the spindle gear to the lead screw. Otherwise the lead screw cannot be rotated. If at all I want to rotate the lead screw, then I have to connect all these gears, okay, then only the lead screw will start rotating. But the selection of these gears means the number of teeth gear selection is very very important whenever we want to go for a thread cutting operation. So that is what we are going to discuss in detail now, one by one. Thread of any pitch or shape and size can be cut on a lathe using a single point cutting tool. This is already told, depending upon whatever the shape, size, okay, can be decided, then we can go for the cutting of the screw threads or thread cutting. Thread cutting is operation producing a helical groove on a spindle shape such as V, square or power threads on a cylindrical surface. As I already told, the job is held between the centers or in a chuck and the cutting tool is held on the tool post, as you are going to see on the screen very clearly. The cutting tool must travel a distance equal to, this is the most important concept here, the cutting tool must travel a distance equal to the pitch in millimeters as the workpiece completes a revolution. So it is very clear now that whenever the thread cutting operation is to be carried out on the workpiece, the movement of the cutting tool has to be controlled. So that cutting tool has to move equal to the pitch of the thread to be cut. That is what we are going to discuss now in detail again. See the next concept. Again we are going to discuss in detail. Try to concentrate, try to listen carefully. First, the workpiece is held between the centers or in a chuck as shown in the figure which you are going to see to the right side. The tool of V or square profile is selected and held in a tool post. That also you are going to see very clearly there. To produce the desired pitch on the workpiece. So we want to produce the desired pitch. It is necessary to feed the tool to a distance equal to the pitch of the thread to be cut per revolution of the spindle and hence the workpiece. This is very very important concept here. Now your workpiece is made to rotate. Okay, so as the workpiece is rotated, the tool has to move in this direction which I have indicated equal to the pitch of the thread. That means if at all the workpiece is made to rotate, okay, through 360 degrees, means only one revolution, then the tool has to move a distance equal to the pitch of the thread. This is possible by using the change gears, which you are going to see here very clearly. These are called as the gears. So these gears are selected in order to give the required movement for the tool post. That is what we are discussing here. This is achieved by selecting the change gears to provide the desired rotation of the gears. How this is achieved? We require to select these change gears are selected. Means we have to calculate what should be the number of teeth of driver gear, also called as a spindle gear, driven gear, also called as a lead screw gear. Okay, and in between these two gears, this is called as a driver gear, this is called as a driven gear. In between that, you are going to see the idler gear, or the gear to fill the gap to give the rotational movement to the lead screw gear. Okay, so now we require to select the number of teeth of these gears for the thread cutting operation. Now I am continuing here. Again, see the next step, again the same one we are continuing in detail. The gear which is mounted on the spindle, the gear which is mounted on the spindle means what? The gear which is mounted on the spindle here, this gear we call it as a driver gear, and the one which is mounted on the lead screw shaft is called as a, this is called as a driven gear. As I have indicated there, it is called as a driven gear. The power or the motion is transmitted from the driver gear to the driven gear. The driven gear, and hence the lead screw, has to be rotated in such a way that it causes the carriage or the tool post or the tool to move through a distance equal to the pitch of the thread to be cut on the workpiece. This I have already informed, and the same one is repeated here for better understanding. So how this is done now, that we are discussing. So again the same figure is continued. As shown in the figure, the following formula is used for the selection of the change gears. What is the formula here? This is very, very important. We have taken the ratio of the driver teeth. What is the meaning of a driver teeth? This is called as the driver teeth, and this is called as the driven teeth. Means the number of teeth of the gear to be selected depending upon the pitch of the thread to be cut on the workpiece. Okay, so here before we proceed with the formula, we need to understand one important concept, that is called as a lead screw pitch. So as you are going to see very clearly, just I have made it slightly larger for better understanding. Now you are going to see the lead screw here. This entire portion is called as a lead screw. Okay, and it is engaged with the carriage, as you are going to see there. So now you are also going to have the threads here which are being cut on a lead screw. So on a lead screw, okay, there are fixed Acme threads of a certain pitch. This pitch is fixed by the machine tool manufacturer. We cannot change the pitch of the thread of the lead screw. Remember, because this, whatever the lead screw pitch is there, that is fixed for a given lathe machine. It may be 5 millimeters, it may be 6 millimeters, or it may be any millimeters. That depends upon the requirement, or even that depends upon the size of the workpiece, or sorry, size of the lathe machine, design, everything. But we need to understand the most important concept, that we cannot change here the pitch of the lead screw. The pitch of the lead screw is fixed. Okay, so that is why using that concept only, we require to understand how we are going to select these gears here. So driver teeth is proportional to the pitch of the workpiece. So here you are going to see very clearly now, the driver teeth is proportional to the pitch of the work. Similarly, the driven teeth is proportional to the pitch of the lead screw. Both are proportional. Using this formula, we are going to calculate the gear teeth, and then we are going to mount those gears for the provision of the required pitch of the thread to be cut on the workpiece. Once the gear ratio, what is the gear ratio? The gear ratio is the gear ratio of the driver teeth, that is the number of teeth present on the driver gear. Driver gear is also called as a spindle gear, divided by driven teeth. Driven teeth means the gear that is provided on the lead screw, that is called as a driven teeth. That is equal to pitch of the workpiece. Pitch of the workpiece will vary. It may be 1 millimeter, 2 millimeter, 3 millimeter, 4 millimeter, 5 millimeter, or even the profile can also change. It may be a V thread, or it may be a square thread, or it may be an Acme thread. So that pitch of the work will vary, divided by pitch of the lead screw. Pitch of the lead screw is given by the manufacturer of the machine tool. We cannot change the pitch of the lead screw. So the only changing values are driver teeth, driven teeth, and pitch of the work. Only changes that can be made on the during the thread cutting operation. Once the gear ratio is calculated, then the gears are mounted on the studs to proceed with the thread cutting operation. Then we can start with the thread cutting operation. So a screw and nut mechanism is used to engage the carriage to provide the required feed for the tool. Once the driver teeth, driven teeth, and pitch of the work, this ratio is selected, then we can start engaging the carriage with the lead screw to start with the thread cutting operation. The tool is brought to the starting point of the workpiece, a small depth of cut using a cross slide. This is very, very important. Once we fix up the selection, the change gears are being selected, then the tool has to be brought to this point. Okay, as I have indicated there, at this point, then the feeding is given with the help of engaging the carriage to the lead screw. Okay, the tool is brought to the starting point of the workpiece, a small depth of cut using a cross slide. The carriage is disengaged once the tool reaches the end of the, so now a very small depth of cut is given, and it is made to traverse in a systematic way. That means in a way that each rotation of the workpiece will cause the tool to move equal to the pitch of the thread to be cut. So once it reaches this end, then again the carriage will be disengaged, again it is brought back to this, again engage, then give us another small depth of cut, and the process will continue till we get the complete thread cutting operation on a given workpiece to the required depth of the thread is reached. So now let us take a simple example here, so that for clarification of this. Now I have taken a very simple example. The pitch of the lead screw is 6 millimeters. The pitch of the lead screw is 6 millimeters, and the pitch of the thread to be cut is 1 millimeter. Find the change gears. How you are going to select the gears? Pitch of the lead screw is equal to 6 millimeters is already fixed one, we cannot change. Pitch of the thread to be cut on workpiece is equal to 1 millimeters. So what is our formula? Driver teeth divided by driven teeth is equal to pitch of the workpiece divided by pitch of the lead screw. So that is equal to 1 divided by 6. That is equal to, I have multiplied here. We are not writing 1 upon 6 as point whatever is coming. That 1 divided by 6 is not, it should not be written in the decimal fractional values. We are not writing in fractional values. We require to convert into the required teeth gear. It can be multiplied with any number. Okay, so 1 is multiplied with the 20 on the numerator, divided by 6 into 20. So why we have multiplied by 20, I will be explaining in the next slide. So 1 into 20 divided by 6 into 20, that is equal to 20 divided by 120. So what is the conclusion? The conclusion says that I have to use the driver gear having 20 teeth. That means I have to select a driver gear which is to be mounted on the spindle of a lathe machine of 20 teeth. Then the driven gear should be of 120 teeth, which is mounted on the lead screw shaft. Then only I can get the pitch of the thread to be cut on the workpiece is equal to 1 millimeters. So now again, as you are going to see on the screen next, so this is the side view. Stud gear which we have selected, whatever the stud gear is nothing but a spindle gear only. It is 20 teeth. Idler gear of any number of teeth only for the speed transmissions. Then you can consider lead screw gear is equal to 120 teeth. Okay. So standard gear teeth. So why we have multiplied by 20? Now it is a standardization. Whenever we want to cut the thread cutting of a particular pitch, we have to select the gears having the number of teeth ranging from 20 to 120 teeth. Means the manufacturer of lathe machine will provide the gears having the teeth on its surface starting from 20 teeth to 120 teeth. Means what? The first gear is having 20 teeth, the second gear is having 25 teeth, the third type gear is having 30 teeth, 35 teeth, 40 teeth, increasing in the steps of 5. This is given by the manufacturer himself. So, and 127 teeth is also given as an extra in order to balance whenever we want to cut the threads in terms of inches. So that is also being given. But so in order to get that these teeth of the required number of teeth of the gear to be selected, we have multiplied here by 20, as you are going to see. As you are going to see here, I have multiplied by 20 here. I have multiplied by 20. So I have multiplied here 1 into 20 divided by 6 into 20. Why I have multiplied by 20? Because I have to get 20 divided by 120. Even I can multiply by, suppose if I multiply by 25, that is also correct. But that becomes wrong because the highest number of teeth available with us is 120 teeth. Suppose if I multiply by 25 into 1, 25 teeth is available, but 25 into 6, it comes as 150. 150 teeth is not available. We are having the largest gear, one which we are having is having only 120 teeth. So we have to select the driver and driven gear ranging from 20 teeth to 120 teeth. Like that only we have to calculate and use the same for cutting the threads on a given workpiece, pitch thread on a given workpiece. So I think I tried my best to see how you are going to select the change gears for cutting of the threads. So definitely you will have more better understanding when you actually start working on a lathe machine. Okay, because on lathe machine in this semester you are going to learn all these operations which I am discussing here practically. In a machine shop, you will be totally coming across all types of lathe machine operations, starting from your facing, rough turning, fine turning, finish turning, grooving, reaming, drilling, boring, thread cutting, taper turning. All these operations you will be doing practically. So you will have a better understanding when you actually start working on a lathe machine in the machine shop in this semester. So now to make you understand what concepts you have to prepare yourself for from the examination point of view, you require to study all the concepts, but in that as a frequently asked question, these are the questions that will be expected to come more number of times in the examinations, like explain the thread cutting operation as applied to the lathe machine. So in this case you have to draw the sketch, you have to explain starting from how you are going to hold the workpiece, how you are going to select the gears, and how you are going to engage the carriage. Three concepts are coming here. So those three concepts, so I have mentioned, I have already explained in the 3 slides. So those 3 slides you just write down and you have to draw the neat sketch and you have to explain. It may be of 5 marks or even it may be of 10 marks in the examinations. And you require to solve these problems as an assignment. Means in the regular notes book only. Calculate the suitable gear trains for the 4 millimeter pitch on a 11 millimeter pitch lead screw. You know very well, driver teeth divided by driven teeth is equal to 4 mm divided by 11 mm. So you can multiply it to the required what we can say numbers to keep that ratio constant. So whenever I am going to multiply the numerator by any number, it may be 10, it may be 15, it may be 20, whatever is there, the same number you have to multiply the denominator to maintain that ratio. Then you can select the change gears. Then you have to draw that sketch, which is very, very important. The pitch of the lead screw is, next problem is, the pitch of the lead screw is 6 millimeters and the pitch of the thread to be cut is 1.5 millimeters. Find the change gear. So you try these two problems. If any difficulty is there, we shall have a discussion in the subsequent presentations, or if not, we shall have a discussion when we actually begin with the offline classes. So with this, I am finishing the presentation of the today's. So you just go through in detail about the, along with this, one video will be attached for better understanding of the today's concept. Okay, thank you.
So I thought I'd share with you the process and method that I use for screw cutting on the lathe. The method I'm going to use is what I would call a sort of intermediate method. It's a bit faster than the beginner's method, and it's a little bit less risky than the slightly more advanced method. I started by getting the shaft roughly to size before cutting the threads. So I've got my shaft turned down to its final dimensions, and we're going to cut a thread on this end here. We're going to cut a 60-degree thread, which is metric. So this little tool here has got an angle on the end of it that's 60 degrees. So the tool shape defines the teeth on the thread. I've cut a little groove in just here so that when I'm bringing the tool across, I've got a little safe space that I can stop the tool before it runs in to this next feature. For screw cutting, we want the machine running nice and slowly. Now for this machine, that's 35 to 180 RPM. Having the machine running nice and slowly means we've got more time to switch off the feeds before we crash the tool into the part. Next thing to set up is the threading gearbox. So we want the lead screw to be cutting a right-hand thread towards the chuck, and we need to look up the thread pitch on the lookup table here. For this is a M14 by 1.5, so 1.5 pitch. Tells me that the selected set here needs to be BS6W, so that's BS6W. Finally, we need to set up the thread dial indicator. If I move the carriage back, you'll notice that this indicator, the numbers rotate. Okay, now that's determined by which of these gears is on the shaft. And to change them, you just undo this nut and select which gear you want. And then that gear meshes with the lead screw. And as the lead screw is turning, it turns the gear, turns the indicator. So we want to cut a 1.5 millimeter pitch thread. So that means we need the gear with 16 teeth, and then there's this little number here, which on this case is numbers 1 to 8. The next one down, 1, 3, 5, 7. The next one down, don't confuse it, it's not 15, it's 1 and 5. What that means is when we want to cut the thread, we can engage the threading by switching on the half nuts. In this case, using any of the numbers 1 to 8. So when this is spinning around, we can start our thread when any of these numbers lines up with this little dimple. So to actually engage and disengage our threading tool, we're going to use this lever just here. This is the half nut engage and disengage. So at the moment, I can move the saddle back and forwards freely, and if I engage the half nut, the saddle now is locked onto the lead screw. So if the lead screw is spinning, that will drag the saddle backwards and forwards depending on which way the lead screw is going. And then we disengage it and we can move it freely again. This means that we can keep the machine running and disengage the half nut at the end of our thread and then just wind the tool back to the start. There's a little bit more to it than that, but we'll get into that in a second. So let's have a go at cutting a thread, shall we? The first thing I like to do when cutting a thread is colour in the area that I'm going to cut the thread on. This gives you a bit more contrast between the cut and the uncut material and shows up any mistakes really quickly, hopefully giving you a chance to correct them. The next step is to just bring the tip of the tool into contact with the part. This is going to set your datum. Now, I like to just move the tool back and forwards along the Z-axis as I'm doing this, so that the tip of the tool scratches a line into the inked surface. That way I don't go gouging it in too far, and I just touch lightly. There we go. We then want to zero out and lock the dial on the X-axis. So this is going to be our depth of cut. So we're starting at 0 on the surface, and then we're going to be cutting in positive. Now, there is a way of doing this, the slightly more advanced way, where you rotate the tool post and you use the compound, but this is a slightly safer, slightly less likely to make a mistake way. So we're ready to take a scratch pass now. So the order of operations is start the machine up with the half nuts off. Okay, so the saddle isn't going to move when you start the machine. Then you wait for your number to come round on your dial thread indicator. When your number comes round, then engage the half nut. When your half nut's engaged, it's going to drag the carriage along, cut the thread. When your tool gets into the gutter, disengage the half nut. With the scratch pass done, the best thing to do now is just have a quick sanity check. Grab yourself a thread gauge and just line it up and check that what you've cut is what you want. So 1.5mm thread gauge, that looks pretty good. What you mustn't do at this point is just bang the tool in reverse and send the tool back the other way, because of the backlash in the lead screw, you'll end up cutting a different thread on the return pass. So the way around that is that we withdraw the tool in the X direction, or the negative X direction in this case, so that it clears. And we've already disengaged the half nut, so then we can just wind the tool back to the start. Now, of course, because we're using the half nuts and we can move the carriage independently now, you can leave the machine running while you're doing this. Obviously not checking with a thread gauge, that would be a bit stupid. But moving this back to the start, you can do this with the machine running. No need to switch it off, saves you a little bit of time. So now we're back at the start. We can bring the tool in and put in a little bit of depth of cut this time. Put a 0.25mm cut on, so that'll take 0.5 millimeter off the diameter. Right, so I'll start the machine up again, waiting for my number to come around. Nearly there, ready and go. And we should be now cutting along the same line that we cut along on the scratch pass. To the end, getting ready to pull the half nuts and half nuts off. Withdraw the tool, bring it back to the start, bring back the depth of cut, so back to 0, and then we'll go in another 1/4 millimeter depth of cut, so that'll take us to 1 millimeter off the diameter. Wait for the number to come round, waiting, and go. So coming up to the end, my hand's on the lever ready and half nuts off. Right, a little test fit with a nut just to check it's right. Now, I've made a little mistake here. I need to go a little bit deeper. But the problem I've got is I haven't made my gutter deep enough, and my threading tool is now starting to cut into the root of the gutter. Now, because we're using this method with disengaging and engaging the half nut, I've got a little bit more flexibility here. Using the really basic method where you drive the machine backwards and forwards, you can't do this because you'll lose your position. But because we're doing this method, I can now come in with a normal cutting tool, sort out this gutter, go back, put my threading tool back in, and with reasonable confidence, go back to the dial, and the threading tool should pick up and refine the thread. So let's give that a go. as a little tip, because I've swapped the tool out and done a load of other operations, what I like to do is just put the tool back in, get the machine going, and then do a cut without actually having any cut on, just to check that the tool lines up with the root of the thread. So you really don't want to screw it up at this point. So my number's coming around, slowly, numbers there, nearly there now, and engage. So I'm just watching the tool to make sure that it lines up with the root of the thread, which it seems to be doing reasonably well. And disengage. So we'll just take a couple of finishing passes now, only taking a little bit now just to smooth up the surface, make a nice finished thread. Right, just knock the tops off, because I think we're about there. A little bit of emery paper and a bit of Scotch-Brite at the end just helps to clean up the threads, get rid of the tool marks, and you always end up with a few little niggles that you need to get rid of. A small toothbrush or a wire brush is really good for cleaning the little bits of swarf out of the threads before you test fit your nut. There we go, finished thread. Let's give that a little test with a nut. That feels nice. Now, there's a couple of ways to do this, the screw cutting on the lathe. There's the beginner's way, where you drive it back and forwards and it takes forever. Good place to start if you've never done it before. And I'd say that this is a sort of intermediate level of doing it. It's not quite as good in terms of tool load as the more advanced method, where you rotate the tool post and things like that, but it's just as fast and it's slightly less risky. Now, if you're just doing small threads like this and you're a hobbyist, I think this is a good way of doing it. If you're doing great big parts, cutting great big threads with big tools, well, I'd use the more advanced method because it's going to reduce the tool load. But small parts, hobby home workshop stuff, I think this is a nice way of doing it. Because like you saw, I made that little mistake, and it's nice and versatile. I could go in, do a little operation with a different tool, come back, pick up my thread where I left off, and I just carried on and no mistakes. And we've ended up with a nice finished part there. So I'll get this parted off, and there's a little hole to drill in the other end, and then I'll get it given back to the person it's for.